Hi, I am Vanessa Mateo together with Glenda Marie Postrado, Carla Joyce Puno, and Ella Jane Timbang for Chapter 9-5, Testing the Difference Between Two Variances. In addition to comparing two means, statisticians are interested in comparing two variances or standard deviations. So, for example, a researcher may be interested in comparing the variance of cholesterol of men with the variance of the cholesterol of women. So, in this case, we have to use the F-test. The F-test should not be confused with the chi-square test, which compares a single sample variance to a specific population variance. So to compare chi-square test and F-test, for chi-square test, we have an instructor wishes to see whether the variation in scores of the 23 students in her class is less than the variance of the population. While sa F-test naman, an instructor may be interested in comparing the variance of the male students from the female students in her class. So as you can see, meron ng comparison between two variances sa F-test, while sa chi-square test naman, there is only single variance under study sa situation. If two independent samples are selected from two normally distributed populations in which the variances are equal, and if the variances or if the sample variances are compared as sample variance 1 over sample variance 2, then the sampling distribution of the variances is called the F distribution. The formula for F values is given by the sample variance 1 over the sample variance 2, where the larger of the two variances is placed in the numerator regardless of the subscripts. The F-test has two terms for degrees of freedom, that of numerator n sub 1 minus 1 and that of the denominator n sub 2 minus 1, where n sub 1 is the sample size from which the larger variance was obtained. The degrees of freedom are denoted as DFN or degrees of freedom numerator and DFD as degrees of freedom denominator. And always remember that the numerator in this formula is given by the larger variance regardless the sample size and subscripts. Now, these are the characteristics of the F distribution. First is that the values of F cannot be negative because variances are always positive or zero. Why? Because variances is given or variance is given by squaring the standard deviation, and whatever the value of standard deviation is, once we square that then the variance will always be positive or zero. The next characteristics of the F distribution is the distribution is positively skewed. Now, this figure shows the family or the F family curves. As you can see, the curves are positively skewed nga, and the tails are on the right. And this is one or the next characteristics of the F distribution. The third characteristic is that the mean value of f is approximately equal to 1. And lastly is that the f distribution is a family of curves based on the degrees of freedom of the variance of the numerator and the degrees of freedom of the variance of the denominator. Kung paano, let us see. I have mentioned earlier that when you are finding the f-test value, the larger of the variances is placed in the numerator of the f formula, and this is not necessarily the variance of the larger of the two sample sizes. So the table H in Appendix C gives the F critical values for alpha 0.005, 0.01, 0.025, 0.05, and 0.10. So for example, we're going to find F critical value for DFN 10 and DFD 5. So hanapin natin yung yung column 10 sa DFN and the row 5 sa DFD. And yung intersection nila will be the F critical values, which is 3.30. Ganun lang kasimple yung paghanap ng finding the F, or paghanap ng F critical value. But this is only for one-tailed test. For two-tailed tests, let us use the same given with DFN 10 and DFD 5 and an alpha of 0.10. The very first thing na we have to do when we are dealing with two-tailed tests is to get the alpha over 2, and whatever value na makukuha natin doon will be our basis to get the critical value. So in this case, ang alpha over 2 is 0.05 since alpha is 0.10. So ang ating gagamitin na table H is the table of alpha 0.05, and the same process lang sa column 10 at row 5 ng DFN and DFD respectively. Yung intersection nila, which is 4.74, will be the F critical value. So that is how we find the F critical values for one-tailed test and two-tailed test. When the degree of freedom values cannot be found in the table, the closest value on the smaller side should be used. So for example, if DFN is equal to 14 and this value is between the given table values of 12 and 15, so ang gagamitin natin would be the column 12 of the table. For example, for alpha 0.05, since 14 is not in the DFN column, then ang ating pagbabasihan ay yung mas maliit na closer value sa 14, which is 12 dahil nasa pagitan si 14 ng 12 and 15.
Example 9-12. Find the critical value for a right-tailed f-test when alpha is equal to 0.05, the degrees of freedom for the numerator or DFN are 15, and the degrees of freedom for the denominator or DFD are 21. So since this is a right-tailed test, we are just going to use the alpha, which is 0.05, or the 0.05 table. Then we are going to find number 15 in the degrees of freedom for numerator in the upper part of the table, and the 21, the number 21 or the DFD on the left side of the table. So number 15 is in here, while 21 is in here. Then we're just going to find out where will they cross, which is in 2.18. Therefore, the critical value is 2.18. Or the critical value for a right-tailed f-test when alpha is equal to 0.05, the degrees of freedom for the numerator is equal to 15, and the degrees of freedom for the denominator is equal to 21 is 2.18. Example 9-13. Find the critical value for a two-tailed f-test with alpha equals 0.05 when the sample size from which the variance for the numerator was obtained was 21 and the sample size from which the variance for the denominator was obtained was 12. And since the given are sample sizes, we are going to decrease 1 in our DFN or for our DFN and decrease 1 for our DFD. So our DFN or degrees of freedom for the numerator is 21. So DFN is equal to 21 minus 1 equals 20, while our DFD or degrees of freedom for the denominator is 12, or DFD is equal to 12 minus 1 equals 11. So our DFN is equal to 20, while our DFD is equal to 11. As stated in the problem, it is a two-tailed f-test. Therefore, we are going to divide our alpha, which is equal to 0.05 by 2. So 0.05 over 2 is equal to 0.025, meaning we are going to use the table H for 0.025. So this is our table H for alpha 0.025. And lately, we know that our DFN, the degrees of freedom for the numerator, is equal to 20, while our DFD or degrees of freedom for the denominator is equal to 11. So we are going to find 20 in the upper part, which is in here, and 11 on the left side. Then we are going to find out where will they cross, which is in 3.23. Therefore, the critical value is equal to 3.23. Or the critical value for a two-tailed f-test with alpha 0.05 when the sample size from which the variance for the numerator was obtained was 21 and the sample size which the variance for the denominator was obtained was 12 is equal to 3.23.
When you're testing the equality of two variances, these hypotheses are used. For right-tailed, we have the null hypothesis will be the population variance 1 is equal to population variance 2, and the alternative hypothesis will be population variance 1 is greater than the population variance 2. Sa left-tailed naman, we have the null hypothesis as the population variance 1 is equal to population variance 2, and yung alternative hypothesis will be population variance 1 is less than the population variance 2. And lastly, sa two-tailed, ang null hypothesis will be same as the population variance 1 is equal to population variance 2, and the alternative hypothesis will be the population variance 1 is not equal to population variance 2. These are the four things that we have to take note when we are using the f-test. First is that the larger variance should always be placed in the numerator of the formula regardless of the subscripts. The second is that for a two-tailed test, the alpha value must be divided by 2 and the critical value placed on the right side of the f curve. The third one is that if the standard deviations instead of the variances are given in the problem, they must be squared for the formula for the f-test. Kasi nga, ang S natin dito sa formula stands for standard deviation. So, once na-square na yan, magiging variances na yan. So, kung ang given ay standard deviation, kailangan natin i-squared yung given. Then lastly, when the degrees of freedom cannot be found in table H, the closest value on the smaller side should be used. Ito naman yung assumptions for testing the difference between two variances. First is the samples must be random samples, yes. And then the populations from which the samples were obtained must be normally distributed. That is why we have a note here that the test should not be used when the distributions depart from normality. And last is that the samples must be independent of one another, of course. Remember that also in test of hypothesis using traditional method, these 5 steps should be taken. The first is to state the hypothesis and identify the claim. The second is find the critical value, then compute the test value, and the fourth and fifth are to make the decision and summarize the results. So, ginagamit din yung traditional method of testing sa comparison ng two variances.
Good day everyone, my name is Ella Jean Timbang from BSED Math 3A. So, this is the continuation of our topic 9.5, testing the difference between two variances. So, we will talk about the 9-14 example, heart rates of smokers. A medical researcher wishes to see whether the variance of the heart rates in beats per minute of smokers is different from the variance of heart rates of people who do not smoke. Two samples are selected, and the data are as shown. So using alpha is equal to 0.05, is there enough evidence to support the claim? So for smokers, we have N1 is equal to 26, and our S1 squared is equal to 36. Then for non-smokers, we have N2 is equal to 18, then S2 squared is equal to 10. So in order to solve this, we will use the traditional method hypothesis testing wherein there are 5 steps. So for step 1, we have to state the hypothesis and identify the claim. So our null hypothesis, sigma 1 squared is equal to sigma 2 squared. And our alternative hypothesis, sigma 1 squared is not equal to sigma 2 squared. Wherein ito yung kiniklaim natin. So for step 2, we have to find the critical value. So we have to use the 0.025 table in table H. So since yung alpha natin is equal to 0.05 and alam natin na this a two-tailed test, then yung alpha natin kailangan i-divide sa 2. So 0.05 divided by 2 is equal to 0.025. So yung 0.025 na table must be used in table H. So here's our given. For smokers, we have N1 is equal to 26. Then for non-smokers, we have N2 is equal to 18. So in order to find the degrees of freedom numerator, we have N1 minus 1. Substitute natin yung given N1. We have 26 minus 1 then is equal to 25. So our degrees of freedom numerator is equal to 25. And in order to find the degrees of freedom denominator, we have to subtract 1 from N2. So N2 minus 1, we have 18 minus 1. Then our degrees of freedom denominator is equal to 17. So let's find the critical value on the table H wherein yung given natin na degrees of freedom denominator is 17. However, di natin makita yung degrees of freedom numerator is equal to 25 sa table H. So, makikita nyo naman na walang 25 sa table H natin. So, anong gagawin natin kapag di natin makita yung degrees of freedom sa table H? So, according sa note for the use of the F-test or yung sa module natin, sa number 4, when the degrees of freedom cannot be found in the table H, the closest value on the smaller side should be used. So, ang degrees of freedom numerator natin is di natin mahanap sa table H. So, ang gagamitin natin is yung mas maliit na side. So, hindi natin makita rito yung 25. So, ang mas maliit sa 25 na nasa may table H is 24. So, we will use the degrees of freedom numerator 24 in order to find the value. So, we have 2.56. So, our critical value is 2.56, wherein ang ginamit nating degrees of freedom numerator is 24. So, andyan yung 2.56 sa ating curve. Andang shaded region is yung ginamit natin na 0.025. For step 3, we have to compute the test value. So, we have here the formula for F-test, wherein F is equal to S1 squared over S2 squared. So, yung given natin, for smokers, we have S1 squared is equal to 36. Then, for non-smokers, we have S2 squared is equal to 10. So, substitute natin siya sa formula. So, F is equal to S1 squared over S2 squared is equal to 36 over 10. Then, our F value is equal to 3.6. So, for step 4, we have to make the decision. So, we have to reject the null hypothesis since yung nakompute nating F value na 3.6 is greater than our critical value na 2.56. So, as you can see sa ating illustration, wherein yung 2.56 natin, na ating critical value, yung nakompute nating F value, which is 3.6, falls on our critical region. So, meaning we have to reject the null hypothesis. So, for step 5, we have to summarize the results. There's enough evidence to support the claim that the variance of the heart rates of smokers and non-smokers is different.
Example problem for chapter 9.5. Example 9-15. Waiting time to see a doctor. The standard deviation of the average waiting time to see a doctor for non-life-threatening problems in the emergency room at an urban hospital is 32 minutes. At a second hospital, the standard deviation is 28 minutes. If a sample of 16 patients was used in the first case and 18 in the second case, is there enough evidence to conclude that the standard deviation of the waiting times in the first hospital is greater than the standard deviation of the waiting times in the second hospital at alpha 0.01? We use the traditional method for hypothesis testing. Step 1, state the hypothesis and identify the claim. Step 2, find the critical value. Step 3, compute the test value. Step 4, make the decision. And Step 5, summarize the results. Following the traditional method in solving hypothesis testing problem, we have Step 1. State the hypothesis and identify the claim. For the null hypothesis, we have population variance sub 1 equals population variance sub 2. And for the alternative hypothesis, we have population variance sub 1 is greater than population variance sub 2, which is the claim in our problem, the alternative hypothesis, and it is a right-tailed test. Next, step 2, find the critical value. From our problem, we have the values n sub 1 and n sub 2, our samples. From the first hospital, we have the n sub 1, which is 16,
And from the second hospital, we have the n sub 2, which is 18. The degrees of freedom numerator n sub 1 minus 1 is 16 minus 1, which is 15. And for the degrees of freedom denominator, we have n sub 2 minus 1, which is equal to 18 minus 1, which is 17. So our degrees of freedom numerator is 15. And the degrees of freedom for the denominator is 17. And our alpha level is 0.01. Next, so we have our degrees of freedom numerator and denominator. We have 15 and 17. And alpha level of 0.01. Now we look at our table H, which is the F distribution table, and locate our degrees of freedom at alpha 0.01. The intersection or the critical value is 3.31. Next, step 3, compute the test value. Our given values from our problem, we have the sample standard deviation. We have standard deviation sub 1 is 32, and for the S sub 2 is 28. Now we substitute them in our formula to get the test value. We have F equals sample variance sub 1 over the sample variance sub 2. Since our given values are in the form of sample standard deviation, we are going to square them. So they will become a sample variance. So we have 32 squared over 28 squared. So our F value is 1.31. Next, step 4, make the decision. So our test value or the F value is 1.31 and our critical value is 3.31. So the decision is to do not reject the null hypothesis since the F value is less than the critical value. We have 1.31 less than the 3.31. Next, step 5. Summarize the results. Since we do not reject the null hypothesis, there is not enough evidence to support the claim that the standard deviation of the waiting times of the first hospital is greater than the standard deviation of the waiting times in the second hospital. Example problem for Chapter 9.5. So next example, we have example 9-16, airport passengers. The CEO of an airport hypothesized that the variance in the number of passengers for American airports is greater than the variance in the number of passengers for foreign airports. At alpha level of 0.10, is there enough evidence to support the hypothesis? The data in millions of passengers per year are shown for selected airports. Use the p-value method. Assume that the variable is normally distributed. And we have this table for the American airports and for the foreign airports. So for this example, we are going to use the p-value method. Step 1, state the hypothesis and identify the claim. Step 2, compute the test value. Step 3, find the p-value. Step 4, make the decision. And step 5, summarize the results. Using the p-value method, we have step 1, state the hypothesis and identify the claim. For the null hypothesis, we have population variance sub 1 equals population variance sub 2. And for the alternative hypothesis, we have population variance sub 1 is greater than the population variance sub 2, which is the claim in our problem. So step 2, compute the test value. Using the formula in chapter 3 or using a calculator, find the variance for each group. So, we find the variance for the American airports and for the foreign airports. Next, so we have our degrees of freedom, numerator and denominator. We have 15 and 17, and alpha level of 0.01. Now we look at our table H, which is the F distribution table, and locate our degrees of freedom at alpha 0.01. The intersection or the critical value is 3.31. So for this example, I use Excel. For the American airports, the sample variance is 246.38. And for the foreign airports, the sample variance is 95.87. So the American airports labeled as the sample variance sub 1, which is 246.38. And for the foreign airports, labeled as the sample variance sub 2, which is 95.87. Next, substitute in the formula and solve. Since our values are in the form of sample variance, we just substitute them and not squared them. So we have 246.38 over 95.87. So the F value is 2.57. So next step, we have the step 3. Find the p-value in the F distribution table using our degrees of freedom numerator, which is 5, and the degrees of freedom for the denominator, which is 3. In finding the p-value in testing the difference between two variances, we are going to locate our degrees of freedom numerator and the degrees of freedom denominator in all alpha level in the table H for the F distribution table. And we locate the interval or the alpha level where the F value falls. So first, we locate our degrees of freedom numerator and denominator at alpha 0.10 in table H. So our value at alpha 0.10 is 5.31. Next, at table alpha 0.05, the intersection of our degrees of freedom is 9.01. And for the table of alpha 0.025 is 14.88. For our table at alpha 0.01, the intersection of our degrees of freedom numerator and the denominator is 28.24. And last, at the table H, at alpha 0.005, the intersection of our degrees of freedom is 45.39. Now that we finish listing and locating our two degrees of freedom numerator and the denominator at all alpha level in the table H for F distribution table, we now locate our F value, the 2.57. We locate the interval or in the alpha level where the F value falls. So as you can see, the closest value for our F value is the alpha level. We have 5.31. And as you can see, the larger the alpha, the smaller the value. But since the F value is less than the 5.31, this means that the p-value is greater than alpha. It is greater than 0.10. Since we already compute our p-value using our table, why we do not try calculating or computing our p-value using a calculator? So I use this online calculator, p-value calculator for F distribution. So I input our values and the p-value I obtained from a calculator is 0.234. So step 4, make the decision. The decision is to not reject the null hypothesis since our p-value is greater than 0.10. Our p-value is greater than our alpha level. Step 5, summarize the results. Since we do not reject the null hypothesis, there is not enough evidence to support the claim that the variance in the number of passengers for American airports is greater than the variance in the number of passengers for foreign airports.
Finding p-values for the f-test statistic is somewhat more complicated since it requires looking through all f tables using the specific DFN and DFT values. So for example, suppose a certain test has f of 3.58, DFN of 5, and DFD of 10, the very first thing that we need to do is to find the corresponding f values for DFN 5 and DFT 10. So, gagamitin natin lahat yung table H ng mga alphas, 0.05, 0.01, 0.025, 0.05, and 0.10. To be organized, we have to make a table like this. And the next thing we need to do is to locate the two values that the test value falls between. So, ang ating F value is 3.58 and that falls between F of 3.33 and F of 4.24, which corresponds to alphas 0.05 and 0.025 respectively. Hence, the p-value for a right-tailed test for f of 3.58 falls between 0.025 and 0.05. And the p-value obtained from calculator is 0.0408. But this is only for one-tailed test. Remember that for a two-tailed test, the values found in table H for alpha must be doubled. So in this case, from between 0.025 and 0.05, the p-value became between 0.05 and 0.10. If the exact degrees of freedom are not specified in table H, the closest smaller value should be used. So for example, if alpha is 0.05 for right-tailed test, DFN is equal to 18 and DFT is equal to 20. Use the column DFN is equal to 15 and the row DFD is equal to 20 to get F value 2.20. So, ang ginamit dito na column ng DFN is the column 15 dahil si 18 ay between sa DFN 15 and DFN 20. So, si 15 is the smaller closest value ni 18. Kaya si 15 ang ating ginamit. So, sa DFD naman is yung row 20 and yung intersection nila is 2.20 and that will be our F value. So, this is for the right-tailed test. It is not absolutely necessary to place the larger variance in the numerator when you are performing the F-test. That is because critical values for the left-tailed hypothesis tests can be found by interchanging the degrees of freedom and taking the reciprocal of the value found in table H. So, in this case, kailangan natin i-interchange yung dalawang degrees of freedom kasi tayo ay left-tailed test na. So, from DFN 15, magiging DFN 20 tayo, and from DFD 20, magiging DFD 15 tayo. And yung intersection nila, which is 2.33, kailangan natin kunin yung reciprocal nun to get the F value, which is 0.429. So, that is for left-tailed test. And this actually ends our report. Again, I am Vanessa Mateo, together with Glenda Marie Postrado, Carla Joyce Puno, and Ella Jane Timbang, and we are the Group 4 presenting Chapter 9-5, testing the difference between two variances. Thank you.